Hi, we're here with Dave Richkas from Microchip. Dave's going to tell us a little bit about Bluetooth, but low energy Bluetooth. Dave, obviously in battery applications and in a lot of areas, energy use is very important. That's why you guys came up with this concept. Tell us a little bit more about how you make Bluetooth low energy and how you're going to demonstrate it for us today.
Sure. Yeah, as you mentioned, Bluetooth low energy modules, as we'll show here today, are perfect for simple command and control type applications. Thermostats, machine control, authentication of a user as they approach a machine or a car or a door lock. So it's a very low energy, low battery power. So it you have long battery life out of a CR2032 type batteries, coin cell.
Right. When you say low energy, how low is low?
Typically, you can run it be in dormant mode at 700 nanoamps and a 3.3 volt module, and transmit, receive, you're up at 15, 16 milliamps for just a very brief amount of time.
That's great. You've got a demo cooked up for us here. Can you tell us a little bit about it?
I sure do. So there are several standard profiles defined by the Bluetooth SIG, heart rate, cadence, battery level, things like that. But many engineers find that those profiles don't fit their particular application need. And so we've received a ton of requests for being able to move serial data over Bluetooth LE. So we created a custom capability which basically turns the interface into a simple wireless UART. We call it MLDP. It's Microchip's Low-energy Data Profile. And what I'll show you here is I have one of Microchip's development boards, the Explorer 16, with a PIC24F microcontroller on board, and an application here, and our RN4020 pigtail. So I have this application configured, and I'll just pull it up here on my phone to talk to this, and you'll see this one's name is John, is that particular board's name. And I've just connected to it. You can see the green LED showing I've connected to the Bluetooth LE module. And with this slider, you can see I can control, you can think of that as like the speed of a fan, or a temperature of some heater in your house. And then also coming back from the board, we communicate back to the phone. So it shows simple two-way communication over Bluetooth LE using just a simple UART type profile, no standard profile that has predefined. So it gives the engineer the flexibility to communicate the way they want to communicate, UART to UART, and something they've been doing for years.
Yeah. If the Bluetooth channel crashes, can you recover?
Yeah, it does. Bluetooth is a hopping technology, so it avoids the noise and interference of other 2.4 gig radios.
Great. So if the Bluetooth channel crashes and there's nobody there, does it make a sound?
Funny. I don't think so.
Dave, it's kind of an interesting board here. Can you point out a few of the components that are appropriate?
Sure. So as you can see here, we have the Bluetooth RN4020 pigtail. Okay, and that's interfaced to the Explorer 16 development board. That Explorer 16 development board has our PIC24F plug-in module, and the code runs there, and we interface to this board through any smartphone.
Dave, can you tell us a little bit about the module itself?
Yeah, sure. It's pre-certified for FCC, Canada, Japan, and Europe, and it has an integrated PCB-based antenna, which we've demonstrated to give us over 100 meters of range in an open-air parking lot test.
Awesome. Well, that's an interesting development, and it's a good way to save energy when you're working with Bluetooth. Thanks, Dave.
Thank you.